All right, this is part 2 of section 4.3 and 4.4, and we are going to practice graphing some logarithm functions. So in this first example here, I'm asked to graph log base 3 of x and log base 3 of x minus 1 plus 2. Now we did log base 3 of x in the previous video, and so I'm going to use the table that we already made in that video. So this is going to be x and f of x. And f of x is log base 3 of x. And we plugged in the points 1/3, 1, and 3. And I'm just going to use those 3 points for all, or only using 3 points for all of my graphs. So when I plug in 1/3, log base 3 of 1/3, that's going to give me out -1. Plugging in 1, log base anything of 1 is 0. And log base 3 of 3 is 1. So plugging all of those in, I end up with 1/3 -1, 1, 0, and 3, 1. And there is that graph. Okay. Now, I'm also asked to graph g of x, and that's log base 3 of x minus 1 plus 2. So I need to shift that graph. This minus 1 is moving my graph to the right 2, and this plus 2 is moving it up. Oops, not right 2, right 1, and up 2. So all of these points are going to move to the right 1 and up 2. So right 1 and up 1, 2. Right 1 and up 1, 2. Right 1 and up 1, 2. And not only that, my asymptote was at the y-axis here, but shifting up and down does not affect it. Shifting to the right one does. So now my vertical asymptote is at that equation x equals 1. And this is the graph of g of x. And when you graph two graphs on the same coordinate plane, you always want to label them. So this one is g of x, and this is f of x. All right. So, and we also want to state the domain and range. So the domain here for I'm going to be stating the domain and range for g of x. So for g of x, it's getting really, really close to x equals 1. So my domain is from 1 to infinity. But my range for all of these is -infinity to +infinity. Let's do a few more here. So number 11, we have negative log base 3 of x. So same equation that we were just working with, but a negative on it. So now my table is a negative log base 3 of x. I'm still going to use those same x values. So 1/3, 1, and 3. And I can still get out those values of -1, 0, and 1, but they're all being multiplied by a negative. Well, negative times -1 is 1. 0 times a negative is still 0. And 1 times a negative is -1. So this negative is going to end up reflecting our graph across the x-axis. So now I have the point 1/3 +1, 1, 0 still, and then 3, -1. So now my graph looks like this, and that is my logarithm graph for f of x. Now g of x has been shifted. It's been shifted to the right 2. So my asymptote was at the y-axis. Now it is shifted to the right 2. So shifting to the right 2. All of my points are also moving right 2. And that is my graph of g of x. Now I also want to state the domain and range. Remember, the domain is going to be changing, so that is going to be shifted to the right 2, so my domain is from 2 to infinity, but my range for all of these is negative infinity to positive infinity. Moving to the next one, we have log or 2 log base 4 and then 2 log base 4 of x minus 3. So I'm going to start with that first one, and I have x, and then can't seem to find a pen that works. X and 2 log base 4 of x. And our base is 4, so I'm going to use 1/4, 1 and 4. And I'm going to normally get out -1, 0, and 1, but these values are all being multiplied by 2. So I end up with -2, 0, and 2. Plotting those points, 1/4, -2, and 1, 0, and then 4, 2. It's stretched my graph by a factor of 2. So this is our graph of f of x. And then my graph has been shifted down 3. But shifting a vertical asymptote down doesn't change where it's at. It's still on the y-axis here. So all of those points being shifted down 3, shifting down 3, shifting down 3. This is the graph of g of x. Okay. And again, domain and range. The domain is 0 to infinity, and the range is again -infinity to positive infinity. 2 more. So here it does not ask us to graph the parent graph. It only asks us to graph this function here. I'm still going to use the points of the parent graph. I'm still going to make my table with 3 log base 2 of x, and then I will shift everything left 1. So I'm going to use 1/2, 1, and 2. I'm going to get out 3 times -1, 3 times 0, and 3 times 1, and that gives me -3, 0, and 3. So I have 1/2 -3, 1, 0, and 2, 3. So you can see that this is really stretched it vertically, but I'm not going to actually draw that curve because they didn't ask for it. They only asked for the shifted graph. So I'm going to move all of these points to the left 1. And moving to the left 1 will also shift my vertical asymptote to the left 1. So now my vertical asymptote is right there at the line x equals -1. And all of these points will move left 1 as well. And so we can see this curve. All right, last example in this section, and we're asked to graph natural log of x and natural log of x plus 3 minus 1. So this graph will be shifted left 3 and down 1. So I'm going to use x and ln of x, and then I have my base, 1 over my base, 1 and my base. Remember that the base of natural log is e, so 1 over e is still going to give us -1. Plugging in 1 to any logarithm is 0, and e will give us 1. Now remember, e is approximately 2.7. So 1 over 2.7 is pretty close to 1/3. So 1/3 -1, 1, 0. And then again, e is about 2.7. So 2 and then not quite all the way to 3 up to 1. And that is the graph of what they're calling y. And then we will graph f of x, which is shifting all of those points left 3 and down 1. Well, again, moving left 3 also moves my vertical asymptote. So instead of being at the y-axis, it's moved left 3 So my vertical asymptote is here at x equals -3. And all of these points are shifting left 3 and down 1. So left 1, 2, 3, and down 1. Left 1, 2, 3, and down 1. Left 1, 2, and 3, and down, down 1. All right, so we can draw that curve. And that is the graph of f of x. And that brings us to the end of sections 3 and 4.